Welcome to the video for 0, 1, and negative exponents. We want to look at what those exponents mean. To do that, we're going to use the um, properties of exponents that we worked with in another video, the exponent rules. So if you haven't looked at that, or if you're not comfortable with that, you might look at that again. Um, or email me if you have questions about that, but we will need those ideas in this video. In our video on the exponent rules, we found the subtraction rule, or the rule for dividing exponential expressions. We found that if we had 5 2's in the denominator, we could cancel 5 2's from the numerator. In this case, we had 2 to the 8th divided by 2 to the 5th power. That gave us 2 to the 8 minus 5, which was 2 to the 3rd power. Now we're going to change it up a little bit. I'm going to start with 2 to the 5th divided by 2 to the 8th, which hopefully you recognize as being a fraction, because the numerator is less than the denominator. So it's not only going to be a fraction, it's going to be a proper fraction. But to do this, I'm going to start out just like we did before. I'm going to rewrite the numerator as 2 times 2 times 2 times 2 times 2. And then my denominator, 6, 7, 8. I'm going to multiply 8 2's together. And just as before, 2 divided by 2 is 1. So we actually have 1. Whenever we have 2 divided by 2, we have 1. Each of those becomes 1. So we have 1 to the 5th power, or 1 times 1 times 1 times 1 times 1, which is 1. So in my numerator, I really have 1. And in my denominator, I have 2 to the 3rd power. So similar to what we did before, except 2 to the 3rd power is in the denominator. I'm also going to use the subtraction rule, though, now, too. And I don't have a lot of room. So I'm going to put a little line in between those. If I do my subtraction rule, I now have 2 to the 5 minus 8, which is 2 to the negative 3 power. So I can now say that a negative exponent is equal to the reciprocal of the positive exponent. So if I have a to the negative b, that's the same as 1 over a to the positive b. So that's what negative exponents mean. And that's going to be important as we get into scientific notation. So make sure that you really feel comfortable with that. But this is the logic behind negative exponents. We can also use that, 2 to the 5th divided by 2 to the 4th. So I have 5 2's in the numerator, and I have 4 2's in the denominator. There we go. I end up with 2. And if I use my subtraction rule, 2 to the 5 minus 4 equals 2 to the 1st power. So anything really is itself to the 1st power. 7 is 7 to the 1st power. A million is a million to the 1st power. First power of 1 is really like multiplying by 1. Doesn't change the number. And another important thing, if I have 2 to the 5th power divided by 2 to the 5th power, and I'm actually multiplying all these 2's together, it's just quicker to do the dots. The dots are hard to do. It's quicker to do the dots all at once. If I divide all of these, I get 1 times 1 times 1 times 1 times 1. I don't remember if that's 5. But anyway, 1 to the 5th power, still 1. I get 1. If I use my subtraction rule, I get 2 to the 0 power. I could have done the same thing with 7 to the 5th power divided by 7 to the 5th power. I'd still get 7 to the 0 power, and I'd still get 1. So even though I use 2 because 2 is an easy thing to think about, any number a to the 0 power equals 1. Little hard to understand, but that's the way it works out. And as I said, doesn't matter what number, doesn't matter what exponent. Five divided by 5 is 1, 1, 1, 1, 1. This equals 1. And if I subtract the 6's, I get 5 to the 0 power. So it does not matter what the base is. You always get the 0. Anything to the 0 power is 1. Let's think about what fractional exponents mean. We know what positive and we know what negative means. What does a fractional exponent mean? And to do this, I'm going to use the multiplicative property of exponents, or the power to a power rule. I have an exponential expression, 2 to the 5th power. I'm raising that to the 3rd power. So I have 5 2's multiplied together. I want to take that and multiply 3 of those together. I end up with 15 2's. So I actually multiply the 5 times the 3 to get the 15. When I look at 9 to the 1/2 power, I'm going to rewrite that as 3 squared to the 1/2 power. Now I can multiply the exponents. 1/2 times 2 is 1. I get 3 to the 1st power, which we saw equals 3. So 9 to the 1/2 power is 3, which is actually the square root of 9. So 1/2 power means the square root. If I look at 8 to the 1/3 power, I'm going to rewrite at 8 as 2 to the 3rd power. When I multiply 3 2's together, I get 8. So I can call the 8 2 to the 3rd power. I raise that to the 1/3 power. 3 times 1/3 gives me 1. So I get 2. 8 to the 1/3 power is 2. That's also, I don't know why that came in at an angle, the cube root of 8, or the 3rd root of 8. So 8 to the 1/3 power means find a number I can multiply by itself, multiply 3 of them together, and get 8. That's also what the cube root means. If I look at the, just in general, what a fraction means, 8 to the 2/3, again, I'm going to call that 2 to the 3rd power. raise it to the 2/3 power, and that's actually like 2 squared. So when I have a fraction that doesn't have 1 in the numerator, that numerator actually becomes an exponent. So I actually take the cube root of 8, which gives me 2, and then I square that answer. So 2 to the 8 to the 2/3 is 2 squared. 8 to the 1/3 is 2.